In this video, we're going to take a look at defining your own custom function. Now, up to this point, whenever we've used any functions, we've specifically taken advantage of functions that were already built into Python, things like the print function or the int function to convert a value to an integer, or the float function to convert a value to a floating point number. We also took advantage of the sum function to add together all of the elements in a list, and the len function to calculate the length of a list as well. Of course, many of the things that you'll want to do in programming will involve packaging up your own code, and one of the key ways to do that is by creating a function that you can then reuse. So our key goal in this particular video is to just introduce the basic syntax of a function in Python and the terminology associated with it, show you how to call the function, and also introduce a couple of other things that are specific to functions in the context of Python. Now, to save me a little bit of typing pain, I'm going to paste in a function definition for a function that we're going to talk about. We are defining here a function named square, and the purpose of this function, as you can see in the next line here, is to calculate the square of a number. Now, for those of you who might be coming from other programming languages, you'll notice that the definition of a function in Python is somewhat different from various other programming languages, especially C-based programming languages where you're typically required to specify the types of everything. That is not how Python works. Python is much more flexible than that. It is a scripting language first, and as a general purpose scripting language, not only enables you to be quite expressive, but enables you to do some very powerful things, as you're going to see through the next many lessons. Now, every function definition begins with the keyword def, which is short for definition. The name of the function is next, and of course, as you define a function, you should give it a name that is understandable, something that has to do with the purpose of that function. And then following the function name will always be a set of parentheses which defines what is known as the parameter list. In the parameter list, you specify variable names that will receive any information that the function needs in order to perform its task. And in the case of our square function, it needs to receive some number that it can then square and return the result. So we have one parameter in this case, but if we had multiple parameters, they would be separated by commas. Notice we say nothing at all about the type of that parameter, which means this function actually could be used, for example, with integers, but it could also be used with floating point numbers. If you happen to pass into this function something for which we cannot use the exponentiation operator, well, then you'll wind up with a syntax error when the interpreter tries to define the function based on the code that you've provided. Now, just like when we have a control statement, the first line of a function definition ends with a colon. In the context of a control statement, we call the lines that are indented within the control statement a suite. In the context of a function, we call those lines a block of code. So a block of code is basically a suite that belongs to a function for the moment, and we'll see that classes also have blocks of code as well when we get to that concept in lesson 10. So we have the colon, we drop to the next line and indent. Again, 4 spaces are the default indentation, and the style guide for Python code specifically recommends that the very first thing you place inside the body of your function is a doc string. Now, you may recall when I introduced triple quoted strings that one of the cases for triple quoted strings is a documentation string, and this is an example of such a string. This is a particularly short example, sometimes when you have more complex functionality or functions that you're defining, you'll have possibly paragraphs of text or much more detail about what a given function does in a multi-line triple quoted string. And towards the end of this video, I'm going to show you how you can access that doc string through the documentation capabilities of the interactive IPython interpreter. And in fact, those same capabilities are available to you through Jupyter Notebooks as well. So here we have a simple documentation string. Notice the 3 double quote characters on either end here. Calculate the square of number. And then we have a 1 additional statement in the body. A return statement, which is going to give a value back to whoever calls this function. So just like when we called the sum function in the preceding lesson to calculate the sum of the numbers inside of a list, and it gave us back the total, the sum, this return statement is going to take whatever number the square function receives, and it will use that value, and it will square that value, and then give back the value that it calculates to whoever calls that function. Now, when you execute a snippet that defines a function, executing that literally just brings the function to life. It is now something that can be executed. It exists at this point, but until you actually call it, nothing happens. So for example, if I go ahead and say square and I give it the value 7, whoops, sorry about that, I give it the value 7 and then I press enter, you can see that I get as a result 49. Now I could have assigned that result to a variable. In this case, I simply had IPython display the value, and this is a really handy way to develop a function and test it out before you incorporate it into a more robust application. As I mentioned, this function does not care what type of number you give it. So for example, I can say square and give it 2.5, which is a floating point number, and it will happily give me back a floating point number as well. So if I give it an integer, it'll give me back an integer. If I give it a floating point number, it'll give me back a floating point number. And by the way, if I give it a decimal, it will calculate the square of that decimal value and give me back the squared decimal value in that case as well. Anything that supports this exponentiation operator can be passed into the square function as an argument to the function. Each argument you pass to a function gets assigned to a corresponding parameter. So when I pass the argument 7 to the square function, number gets assigned the value 7. So I'm doing 7 squared down here, and when this return statement executes, the value is returned back to the snippet number 2, where the IPython interpreter then uses that value as the output result. And the same basic thing is happening down here in snippet 3 as well. Now, one thing to know about Python that's a little different from other languages is that when you return from a function to the caller of that function, something is always returned back to the caller, whether you have a return statement or not. If you have a return statement, then the expression to the right of the return is what is going to be given back to the caller. If there is no expression, there's actually a value in Python called none that gets returned. So that's actually an object that represents nothing, and you can actually use that in your code to test and see whether a function returns something or not if you need to test for things like that. And we'll use the none value in later lessons. So if I have an empty return statement, the value none gets returned to the caller, or if I have no return statement whatsoever, the value none also gets returned to the caller as well. Now the variable number, the parameter number that we defined back here in the square function, exists only for the lifetime of the function's call. So when you call the function, the variable number is now available for use. It receives the argument that you pass. when the return statement finishes executing, then the variable number goes away, and I would not be able to use that down here in my subsequent snippets of code. So if I try to go ahead and autocomplete or tab complete the word number, it's not doing anything as I type the tab character here because it doesn't know what number is. And if by any chance I were to try to evaluate number, you'll see that you get a name error because number does not exist once a given function call to the square function completes execution. It only exists during the call. Now, another thing I want to talk about is, again, this docstring here. So it turns out that in IPython, there's a handy character that you can attach to something to look at its help documentation, and that character is a question mark. So I can go ahead and type square followed by a question mark, square being the name of my function, and automatically the IPython interpreter will display information like what you see here. The first piece of information that it gives me is the signature of the function. The signature is the name of the function and what parameters it expects to receive. So that is something that, as we'll talk about in more detail later, is important because it helps Python decide which function gets called when you have an expression like here in snippet 2 or snippet 3. So it's going to look in particular for a function with the name square that takes one argument in each of these cases, and we have a square function that takes one argument, or one parameter I should say, called number in this particular case. The next thing it shows you is the docstring associated with that function. So even, for example, using the sum function that's built into Python, I can go ahead and say sum question mark and get details about that function that's built into the language. Now, I won't go into all the details of what's going on here, but you can see that it's giving me the docstring, which for the sum function is a little bit more elaborate than what I had for my square function up above. It also tells you the type of that item is a built-in function or method, something that's built into Python, as opposed to a function that I defined myself back up above in this session. If the source code for the function is available to you, you can also take this a step further and use two question marks, in which case not only will it give you the signature of the function, it will give you the full source definition of that function as well. So here is the actual definition of the function. By the way, up above it did this as well. It's telling me where this function is defined. In my case, I'm working in the Chapter 4 folder, which is the set of examples that correspond to Lesson 4 of these videos, and it's telling me that the function was defined in IPython input number 1, which was snippet number 1 back up here. So that's what this information means. This last piece is actually a hexadecimal unique ID code that just identifies the function in memory, and that's something that you can simply ignore in any messages where you see something like this. But again, it says the type of that thing is function, and I don't believe the sum function is available to us, but we can go ahead and check, and what you see here is it did not give us the details of the sum function. So what happens when you use two question marks and the source code is not available is it simply gives you the same result as using a single question mark to access the help information about that function. So those are a couple of nice little tricks that you can use to learn about things. When you start importing other libraries, so for example, we had imported the statistics library back in the preceding lesson. So, whoops, I didn't spell it correctly. There we go. So if I import the statistics library and I want to know more about it, I can go ahead and apparently I can't type very well here. I can learn about the statistics library by simply typing its name and a question mark, and now it starts giving me more detailed information about the statistics library. So as you can see, it's actually not done giving me information about the statistics library. When it is done, I'll get my next input prompt back, but I can now simply use the arrow key to move down, or I can press the space key to move down in bigger chunks at a time. Now you can see end at the end here, and excuse me, when the end is displayed, you can go ahead and type a Q and it will return you back to the prompt so that you can input your next snippet of code in the current IPython session. So if the full documentation can be displayed all at once, it will automatically give you your in prompt back. If the full documentation cannot be displayed in the vertical amount of space available to you on your screen, then you'll simply see a colon until eventually the documentation has been fully displayed. Then you'll see that word end, and you just press the Q to quit from the help system.